Okay, now so let's start our today's class. So this is lecture 9 on discrete mathematics, and in this lecture we are going to start distribution problems. Okay, so we have broadly four types of distribution problem. First is distinct to distincts. That means distinct objects we are having and we want to distribute them among distinct objects. Okay. Next is distinct to identical. Third is identical to distinct, and fourth is identical to identical. So distinct to distinct, this is known as ordered partition. We call it as OP. Distinct to identical, that is known as unordered partition, that is known as UOP. Identical to distinct, we have already done this by the formula was n minus 1 plus RCR. I think you remember we have done this. 10 identical balls, we want to distribute them in 4 boxes and so on. So identical things we want to distribute among distinct things. Okay, so we have done it. Formula was n minus 1 plus RCR. And last is identical to identical. Yeah, so let me start these distribution problems. So the very first is distinct to distinct. Let me jump to the next slide now. Let's take a snapshot.
Done, sir.
Yeah, so distinct to distinct. See, for this we have called it, see the previous slide, we have called it as OP or ordered partition. Why we are calling it as ordered partition? For example, I will say we have 10 toys and you want to distribute them among 3 children A, B and C. Okay, and we are calling it as OP, ordered partition. Why? Because here order matters. Why order matter? For example, if I give two toys to A, okay, 5 toys to B and 3 toys to C. This is different. This is different combination, and another can be 5 2 3, another can be 3 2 5 and so on. So all these are different. Are you getting it? So 2 5 and 3, 5 2 3, 3 2 5. Okay, all are different. But if I say I want to distribute distinct objects among identical objects, then I will say divide 10 toys in 3 groups. So now 2 5 3 or 5 2 3 or 3 2 5, all these will be same. Hence we call it as UOP or unordered partition. Okay, unordered means order does not matter. Order does not matter. OP means order matter. So please try to follow the language. Language is distribute 10 toys among 3 children. That is the basic meaning of ordered partition, because all the 3 children will be obviously different. But if I want to say divide 10 toys in 3 groups, so these groups, it hardly matters. Now first group 2 5 3 or 5 2 3 and so on. So they are same. Okay, so let me write the language. So the language is so by language you have to guess in gate exam what they want to say. Okay, so question number 1 is distribute 10 toys between 3 childrens or between 3 children. That is the question of OP, because here order matters. 2 5 3, 5 2 3, 3 to 5, all are different. Okay, but question number 2 is divide. As soon as you see the word divide, you will say okay, that is for UOP or unordered partition. Divide 10 toys in 3 groups. I am not using the word children and all, I am using the word 3 groups. So similar, immediately you will say okay, it is the question of UOP. Anyhow, we will see all these in detail and how to solve this type of question. I was just giving you an idea that how you will identify whether the question is of OP or whether the question is of UOP. So distribute 10 toys among 3 children, that is OP, and divide 10 toys in 3 groups, that is UOP. Okay, so I hope you have got it. Please take snapshot. I will jump to the next slide.
Done, sir.
So now we are going to start OP. That means the first category, ordered partition, distinct to distinct. So we have 3 categories of problem. First is distribution is fully specified, second is distribution unspecified, third is distribution partially specified. Okay, so the first category is distribution fully specified. So let me tell you this thing. Fully specified means what? We will specify each and everything. Like for example, I want to distribute 10 toys in 3 children A, B and C, such that A will get 10, A will get 3 toys, B will get 5 toys, C will get 2 toys and so on, like this. Okay, so we will fully specify each and everything. Okay, yeah, so let me do it here itself. So how I will say, so I will not write a entire question, I will simply give you hint. For example, I will say I am having 10 toys and I want to distribute them in 3 children, A, B and C, such that A get 2 toys, B get 3 toys, C get 5 toys. Okay, so how many ways to do this thing? So this is simple question. So what I will say, 10 toys are there now and I want to give 2 toys to A. So from the 10 you will choose 2 toys and you will give them to A. So 10C2. Okay. From after doing 10C2 we have given 2 toys to A. Now our work is not yet over because now I want to give 3 toys to B. So how many are left? Since 2 toys have been given to A, so how many are left? 8 toys are left. From these 8 I will give 3 toys to B. Now our work is not yet over. I will then see 5 toys are left now because 3 are gone. From 8 3 are also gone, so 5 are left. From 5 I will give 5 toys to C. Are you getting it? So why I'm doing multiplication? Because my work is not yet over. After giving 2 toys to A, my work is not yet over. I have to give 3 toys to B also. So since 2 I have already given, so how many are left? 8 are left. So from 8 I will choose 3 toys and give to B. So now how many toys are left? 5 are left. From the 5 I will choose 5 and I will give to C. Okay, so this is the simplest way to do this problem. And if we try to simplify it, let me show you how it will come. I want to give you a general formula. So how we will get it? See, 10C2 I think you already know, 10 factorial divided by 8 factorial, 2 factorial. 8C3 means 8 factorial divided by 5 factorial, 3 factorial. 5C5 means what? 5 factorial divided by 5 factorial, 0 factorial. I think there is no doubt in all these things. So 8 factorial cancelled. 5 factorial, 5 factorial cancelled. Okay. And finally, what we will have, 0 factorial is 1 only. So we can simply cancel it. So finally, what we will get? Our answer will be 10 factorial divided by 2 factorial, 3 factorial, 5 factorial. This is the beauty of this concept. So finally we have got what? 10 factorial, 2 factorial, 3 factorial, 5 factorial. And if you try to link, this is nothing but your Mississippi type of problem. Okay, so I think you have got it, na? A trademark problem, Mississippi type. So yes. 10 factorial. So yeah, so 10 toys distribute 2 toys to A, 3 to B, and 5 to C. So 10 factorial divided by 2, 3, and 5. This is my final answer. Very, very simple scenario. Similarly, if I give you another question, like we have 12 toys. Okay, we have 12 toys and we want to distribute them between 4 children, A, B, C, and D. And A should get 4 toys, 3 toys. B should get 4 toys. C should get say 3 toys. 3, 3, 9, 9 or 4. Okay, it is going up. So let us say we have 4, 3. Oh, okay, yeah, it was okay now. 4, 3, 7, 7. And 3, 10. Okay, 10 is there, so 2 are remaining. Yes, so 2. So 12 toys I want to distribute in such a way that 3, 4, 3, 2. So 3, 3, 9, 9. So 3, 3, 6, 6, 4, 10, and 2, 12. Okay, it's fine now. So how we will do it? So simply I will apply the formula and get the answer. 12 factorial divided by 3 factorial, 4 factorial, 3 factorial, 2 factorial. That's it. Very simple scenario. Okay, and another question, if you want, I can write like this also. For example, I have 10 toys and I want to distribute them in 3 children, 3, 3, and 4. Very simple. 10 factorial, 3 factorial, 3 factorial, 4 factorial. So we have 3 children, A, B, and C. We want to distribute 10 toys and 3 children, A, B, and C. A should get 3, B should get 3, C should get 4 toys. So 10 factorial, 3 factorial, 3 factorial, 4 factorial. This is my answer. So very, very simple now. Okay, so distribution is fully specified, then it's really very easy. We can do it directly. Please take snapshot. I will jump to the next slide and then we will start distribution unspecified.
So,
yeah.
If we compare this to Mississippi problem, like that, it means that the children who are getting 2 toys, the toys are alike, identical.
No, actually, by chance, formula is coming same. I was just linking the formula.
Oh, all right, sir. All right, sir.
Okay, so yeah, so mathematically they are same, but logically they are different.
Okay, sir.
So let me write it. This is a good point. If you want to link, I will say mathematically. Let me write it.
Yes.
Mathematically, they are identical. Formula is identical. Okay, but logically they are different.
All right, sir.
Yes. So let me jump to the next slide now. Next is unspecified. If distribution is unspecified, so how we will do it? For example, I will say distribute 10 toys among 3 children. So we have total 10 toys and I want to distribute them among 3 children. So I will make, simply I will do the box method. Okay, so 10 toys. So first toy, 3 choices. It can go to either children 1, 2 or 3. Second toy, 3 choices. Third toy, 3 choices, and so on up to 10th toy, 3 choices. So total 3 multiplied by 3 multiplied by 3, 10 times. So it comes out to be 3 power 10. So I hope I have made the point clear. This is really very simple scenario. Okay, so distribute 10 toys among 3 children. Since all are distinct, nah, these 10 toys are distinct and 3 children are also distinct. So obviously first toy is having 3 choices. It can go to the children 1, 2 or 3. So why 3 choices? It can go to children 1, it can go to children 2, it can go to children 3. This is toy number 1. Toy number 2, same scenario. Toy number 3, same scenario. Up to toy number 10, same scenario. Okay, each and every toy can go, is having 3 choices. Okay, so finally 3 power 10 is our answer. Okay, so now I think you have got it. It's really very simple. So if you want, then I can show you other examples also. For example, I will say that we have 13 toys and I want to distribute them among 4 children. So simply you will see the answer to be 4 power 13. If I am having 15 toys and I want to distribute among 5 children, what will be our answer? 5 power 15. And similarly, if we have 3 toys and I want to distribute in 5 children, okay, so 3 toys, 5 children, so obviously 2 children will not have any toy, or rather we should say at least 2 children will have no toy. Okay, so what will be our answer? Same, 5 power 3. Yes, so I think you have got it, na? So three toys I want to distribute among 5 children. So 5 power 3. Why I am getting 5 power 3 as answer? See this. We have 3 toys. So toy number 1, it has 5 choices. It can go to either children 1, 2, 3, 4 or 5. Are you getting it? 5. So yes. So it can go to C1, C2, C3, C4 or C5. That's why I am saying 5 choices for T1. Similarly, 5 choices for T2, 5 choices for T3. So final answer is 5 power 3. Okay, so I do not want to give you any formula and all. I am just showing you the idea, because if I give you a formula, you will by heart it, and unfortunately in GATE exam you will find a twisted question and you won't be able to answer it. So better is try to grab the concept. No need to by heart any formula or other kind of thing. Okay, so the basic idea is 13 toys are there and we want to distribute among 4 children. So each and every toy is having 4 choices. It can go to the children 1, 2, 3 or 4 and so on. Yes. And if you want to do reverse process, then obviously it is meaningless. For example, here if I say distribute 10 toys among 3 children, so you in box method, if you want to say this is children 1, children 2, children 3, so children 1 is having how many toys? I really don't know how many toys we can give him. Okay, so you may wonder that we can it is having 10 choices, that C1 can have either toy 1, either toy 2, dot 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 up to toy 10. It can have 10 choices. So directly you want to say that children 1 will get only 1 toy. That is the biggest thing. Okay, but we do not say, we are not saying like that children 1 will get only 1 toy. Okay, because if you say 10 possibility here, then obviously it will be meaningless. It means children will get only 1 toy. Similarly, children 2 will get only 1 toy. Children 3 will get children 3 will also get only 1 toy. I do not want to give only 1 toy to them. Na? Okay, so that's why 10 power 3 is wrong. So you will say like here 10, here 10 and here 10. Final answer is 10 power 3. This is clearly wrong. Clearly wrong concept. So do not try to by heart the thing. Try to understand each and everything meaningfully. So finally we have got it, and I am repeating again and again, I am not giving you any kind of formula, because the moment I give you formula, it will be difficult for you to grab the things. And obviously in formula oriented questions will not come in GATE exam. Okay, so no need to do formulas and all. Okay, please take snapshot. I will jump to the next slide.
Done.
So next is category number 3, that is distribution is partially specified. Okay, so the first category was distribution fully specified. That was very easy. Second category, distribution is unspecified, totally unspecified. This is, we have done it. So, and the last is distribution is partially specified. Partially specified means we will give some constraints. We will give some constraints. Okay, for example 4 toys and we want to distribute them in 3 children, and condition is that each child must get at least one toy. So how we will do it? So each child must get at least one toy, so one to him, one to him, and one to him, you have to give it. Okay, and then only one toy is left with you, so now it's your wish whether you give it to A, B or C. So finally I will say like this, either like this or like this. So finally it will be 2 1 1 1 2 1 or 1 1 2, and all these are different. Please do not say they are identical. No, they are different. Why? Because either A will get two toys, here B will get two toys, and here C will get two toys. All are different ways. Yes, so finally, so distribution partially specified, I have converted it into distribution fully specified. So this is one of the fully specified way. So I think you already know 4 factorial divided by 2 factorial, 1 factorial, 1 factorial. So 1 factorial is over. Okay, I can simply remove it. Similarly here, 4 factorial divided by 1 factorial, 2 factorial, 1 factorial, same. 4 factorial divided by 1 factorial, 1 factorial, 2 factorial, same. So finally, uh, all these will be added now, because this is one of the way, or this way or this way. So finally 3 multiplied by this will be my answer. Okay, if you have any doubt that why I have got it, so let me do it properly. Okay, so I will say like this, 4 factorial divided by 2 factorial, 1 factorial, 1 factorial, plus this 4 factorial, 1 factorial, 2 factorial, 1 factorial, plus this 4 factorial divided by 1 factorial, 1 factorial, 2 factorial. So same, obviously. Okay, 1 factorial, 1 factorial, all this will be gone. So 3 into 3 into 4 divided by 2 factorial is my answer. Now please take snapshot. I will jump to the next slide. And one more thing. Okay, and one more thing, try to do everything meaningfully. So for example, here 2, here 1, and here 1. Why I am getting this answer? 4 factorial, 2 factorial, 1 factorial, 1 factorial. Just to revise why I am getting it, I will say like this. So 2 toys I want to give to A. From 4 I want to give 2 toys to A. So 4C2. Our work is not yet over, because now 2 toys are left and I want to give 1 toy to B. So that will be 2C1. Now our work is not yet over. 1 toy is left and 1 toy I want to give to C. 1C1. So finally, when I will you can say open it up, I will get answer as 4 factorial, 2 factorial, 1 factorial, 1 factorial. Okay, yes, so try to remember proof and all these things, then you will get more clarity in, while doing the things. Okay, yes, now take snapshot. I will jump to the next slide. So same type of question, partially specified, that means some constraint I have applied. So 5 toys are there, A, B, C, and each child at least 1 toy. So what are the ways? So 1 1 1 I have to give. Okay, and then what are the other possibility? So 1 1 1 I have to give. Okay, and then I will start the possibilities. So 2 toys are more na, so I will say I give here 1 and here 1. Okay, so let me write it now properly. So 1 1 1, and then I will make it as 2, make it as 2, and similarly I will make these 3 choices immediately from this one, because now order matters na. So 2 to 1, so I will make immediately other combination, 2 1 2 1 2 2. Now let me now see the other possibility. What is the other possibility? So 2 toys were left with me, so I have given 1 1 2 2 children. I can give both the toys to one children also. So 3 1 1 or 1 3 1 or 1 1 3. As soon as I get it, I immediately make other combinations. Are you getting it? So this is the way to do the things. Okay. So now finally we have got this thing. Okay. Yeah. So any other possibility? No, there is no other possibility. You can check it out yourself. Okay, yes, so finally what will be our answer for these 3? Now I think I should not waste the time. I will simply say 3 multiplied by 5 factorial divided by 2 factorial, 2 factorial. 1 factorial is 1 only, forget about it, plus for this 3 multiplied by 5 factorial divided by 3 factorial. So solve and get the answer for it. Yes, any doubt? Okay, so I think there is no doubt now.
No, sir.
Okay, so let me jump to the next slide. Next is, so 20 toys are there and I want to distribute them among 3 children A, B and C, and I am saying A should get exactly 2 toys. What is the way? A should get exactly 2 toys. So see, I have just applied the constraint. So that is the beauty of gate exam. This type of question will be asked. Okay, so if I give you formula and you will by heart it, then obviously you will get confused in gate exam. So always I am trying to say, try to remember the proof. So A should get exactly 2 toys. So you just choose 2 toys and give to A. So 20 C2, from 20 toys you give 2 toys to A. For rest other there is no restriction. Okay, so 18 toys are left, and now I want to distribute 18 toys in these 2 children only, B and C, because A should get exactly 2 toys. See this, A should get exactly 2 toys. So I have given 2 toys to A. My work is over for A. Now I have left with 18 toys, and now I want to give 18 toys to B and C. So what are the ways? So I will simply say like this: 18 toys you want to distribute among B and C. So I have not given you anything. So you will say distribution unspecified. Unspecified. So I think you have got it. So I will simply say by box method. So 18 boxes I will make, and I will say for first toy 2 choices B or C. Second toy 2 choices B and C, and so on. So multiplied by 2 power 18. Okay. Please let me know if you have any doubt. Otherwise, we will jump to the next slide.
Understood, sir.
Okay, so let me jump to the next slide. Next is 20 toys, and I want to distribute among 3 children A, B and C. A should get exactly 3 toys. Same. 20 C3, 17 are left, so 2 power 17. So simple. Okay, I will jump to the next slide now. So 20 toys A, B and C we want to distribute. A should get at least 1 toy. This will create problem for us. A should get at least 1 toy. Okay, so if you try to think about it, then you will really get confused that what should we do, because there are many cases. A should get at least 1 toy. So A should get 1, A should get 2, 3, 4, 5 and so on, many cases. So I have told you many times, whenever we are getting many cases, then complementary method is the best way. So what I will say, A should get at least 1 toy. Complement of it will be what? A should get no toy. Okay, so A should get no toy. Complement is A should get no toy. So A should get no toy. How many ways? So 20 toys are there. A should get no toy. That means he should get 0. So obviously all the 20 toys will be distributed among B and C. So how many ways? Obviously 2 power 20. And total ways, if there is no restriction, then 20 toys are distributed among A, B and C. So each and every toy is having 3 choices. So 3 power 20 total minus this 3 power 20 minus 2 power 20. This is my answer. Okay, so this is the total ways. This is the total ways, and this is what no toy to A. That's it. Please take snapshot. I will jump to the next slide.
Done, sir.
Okay. Next is 20 toys, and I want to distribute them in 3 children A, B, and C, and they should get at least 2 toys. Same. Complementary method. So what I will say, universal is what, or total is what, 3 power 20. So if there is no restriction, then 3 power 20, and then A should get minus. Complement of it will be what, at most 1. At most 1 means 0 or 1. So 0 toy. 0 toy means 2 power 20, or 1 toy. Exactly 1 toy to A. Exactly 1 toy to A. 1 toy to A means what? 20 C1. I have given 1 toy to A, and rest other 2 power 19. Okay, for 19 toys there are 2 possibility for each and every toy. So 2 power 19. I think you have got it. So this is what, 0 toy to A, 0 toy to A. This is what, 1 toy to A. So whenever you have lots and lots of cases, complementary method is the best method. So this is the total. At least 3, I think this is very obvious. So I will simply copy it, and I will just simply add one more thing. So at least 2 also, no? Sorry, exactly 2 also. 20 C2 multiplied by 2 power 18. So 2 toy to A. That's it. This is my answer. Okay. Now you can take, yeah, and one more question is left. I have written here. So 20 toys, and I want to distribute between three children A, B, and C, and A should get at most one toy. So I think this answer will be copy pasted as it is. So this is my answer. That is the beauty of doing questions. Na? So if you do one question, other questions are very simple. At most one toy means what, 0 toy to A or 1 toy to A. Same scenario. We have got it. Okay. Now take snapshot. I will jump to the next slide. Next is unordered partition. So order partition is over now. So in order partition, we have done three categories. See this, we have done three categories, and everything is, I think, crystal clear. Distribution fully specified, unspecified, and partially specified. Partially specified means constraints, and I have done many constraints with you. Okay, so many constraints we have done. So these three are over. Ordered partition is over. So now we will start unordered partitions. That means distinct to identical. Ordered was distinct to distinct, like divide distribute 10 toys between three children. All the three children are different, but here we will say divide 10 toys between three groups, or make three groups of 10 toys. Okay, from make three groups from 10 toys, like this they will ask. So groups are identical. Okay, so like this, see this, divide 10 toys in four groups such that two groups have two toys each and two groups have three toys each. So this is the way, this type of questions we will have to do. Okay, so let me do it. So how we will do it? So what I am saying, divide 10 toys in four groups. Divide 10 toys in four groups. So these are the, now please do not say G1, G2, G3, G4. If you will say like this, then obviously you will consider all the groups to be different, and obviously then order will matter. So I'm not saying order here matters. So all groups are, you are simply making a bunch of toys, na? Okay, so from 10 toys you are picking two toys and you are making one group. Okay, then another group. So just imagine that you have four polythene, and from in each polythene you are adding toys, and all these polythenes are alike, like all these four polythenes are of white color. So now it hardly matters in which polythene you keep how many toys and all. That means order does not matter. Okay, order does not matter. That is the basic thing. So now divide 10 toys in four groups such that two groups of two toys each, two groups of three toys each. So 2, 2, 3, 3, like this. Are you getting it now? So what will be our answer? So for this our answer will be 10 factorial divided by same, just like that only, just like OP, 2 factorial, 2 factorial, then 3 factorial, 3 factorial. But problem is these two. Okay, so 2 are repeated 2 times, so I will divide by 2 factorial, and this 3 is repeated 2 times, so again I will divide it by 2 factorial. I think you just try to imagine this. I am not going into proof, it will simply waste our time. So whenever you will get the same, then you will divide by that much factorial. Okay, so this is my, because here order does not matter, that's why. Okay, yes, so I hope you have got it. So this is my final answer, and let me show you another questions also. Okay, and even if you want me to give you a very small hint, then I can give you a very small hint. See, I am labeling the polythenes just because I just want to give you a simple proof, that's it. So I will say like this. See, if you say 2, 2, 3, 3, or you say 2, see, you label it as what, 2, 1, 2, 2. Now you will say 2, 2, 2, 1, 3, 3. So both are same now. Okay, because A, B, C, D are identical, that's why. So I have just labeled it so that you get more clarity. Like 2, 1 means actually these are not 2, 1 and 2, 2. I am just labeling them so that you get clarity that I have just this 2 is shifted here and this 2 is shifted here. Actually both are same, they are not different. So that's why these two will be same. So divided by 2. So more precisely I will say divided by 2 factorial. Similarly for here I will divide it by 2 factorial. I have just given you a small hint, and if you are able to get it, then it's okay. Otherwise you can simply leave it. The only thing is it is just like your ordered partition only. If you have something common, then divide it by that much factorial. That is the basic way. Okay, yes. So and let me solve another question. For example, if I say 10 toys in 5 groups of 2 each, that is simple question. So 10 toys, 5 groups of 2 each, 2, 2, 2, 2, 2. So what I will say, 10 factorial divided by 2 factorial, 2 factorial, 2 factorial, 2 factorial, 2 factorial, 5 times. So I will divide it by 5 factorial also. This is my final answer. Okay, yes, and this is another question. So distribute 10, divide 10 twice between 4 groups, 3 groups of 2 each and 1 group of 4. So what will be our answer? 10 factorial divided by 2 factorial, 2 factorial, 2 factorial, 4 factorial. 2 factorial is repeated 3 times, so I will divide it by 3 factorial also. So this is my final answer. That's it. Okay, so this is the way to do the things. Yes. So please take snapshot. I will jump to the next slide. Okay, yes. So and gate example, please do not get confused. I think it is obvious thing, but let me write it. So you can write it like this also. 2 factorial power 5, 5 factorial, like this. So I think you have got it, na? 2 factorial into 2 factorial 5 times were there. So that's why I have written power 5. Okay.
Yes.
Let me jump to the next slide. So next question is, so and you have to remember, for UOP we will study only one category, that is fully specified. So there is no partially specified or unspecified category for UOP, because that will be really very tough and it is out of scope for GATE. So we will study only one category, that is fully specified. Like this, I have given you fully specification now. So 10 twice in 4 groups, 2 group have 2 each, 2 groups have 3 each, and so on. Like 10 twice in 5 groups, 2 each, 10 twice 2 2 2 and 4 and so on. So I'm giving you each and every proper fully specifications I'm giving. Okay, I'm not saying constraint and all, because that will be very difficult. Okay, so next is last question. How many ways to divide 2t twice, 2 groups of t each and t groups of 2 each? So just try to think about it. Okay, and after 5 to 10 seconds I will start to answer this question. This is really confusing, and sometimes this type of questions have been asked in GATE. So this type first, so if you try to make a figure, you will get more clarity. 2t twice are there and 2 groups of t. It's so simple, t and t, that's it. What this is saying, 2t twice were there and you want to make t groups of 2 each, na? So 2 2 2 dot 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 2, so you have made t groups. So what will be answer for it? 2t factorial divided by t factorial, t factorial. T factorial is repeated 2 times, so I will divide by 2 factorial also. What will be answer here? 2t factorial, okay, divided by 2 factorial, or rather I should say like this. See, I have said 2 factorial power 5, so I will use this thing. So 2 factorial power t, because 2 factorial 2 factorial 2 factorial t times, so power t, and t factorial also multiplied by t factorial also. Why? Because 2 factorial is repeated t times, that's why. So this is my answer. Okay, so these two statements are confusing, that's why I have given you the solution to this question. Yes, if you have any doubt you can ask me, otherwise I will jump to the next slide.
So we'll do it again, I think.
Okay, we should do it again. Okay, no problem. How many ways to divide 2t twice? 2 groups of t each. What do you mean by this? Have you got the figure?
Yes, sir.
Okay, so 2t, so tt. So now simply you do 2t factorial. Okay, and here t factorial. So this is repeated 2 times, so I have divided by 2 factorial.
Alright.
For this, so t groups of 2 each. So 2t twice were there, and you want to make t groups of 2 each. So 2 2 2 2 2. And how many groups are there? T groups are there. So that's why you will get 2t, na? Okay, 2 2 2 2 2 t times 2 2t. 2t is this. So now how we will do it? 2t factorial. This is total, na? So 2t factorial divided by 2 factorial 2 factorial 2 factorial. How many times it will be there? T times it will be there. So 2 factorial power t. Why? Because 2 factorial multiplied by 2 factorial multiplied by 2 factorial and all. That will be 2 factorial power t. And how many groups are there? T groups were there. So 2 factorial is repeated how many times? T times it has been repeated. So t factorial will be divided. Yes, any doubt?
Yes.
Okay. So, yeah, any doubt?
No, sir, clear.
Okay, okay. So let me jump to the next slide now. So the next is we have say 10 toys and we want to get to 10 toys. We want to make 3 groups, 2, 3 and 5. So UOP, if UOP is there, what will be our answer? 10 factorial, 2 factorial, 3 factorial, 5 factorial. And if we say we have 10 toys, we want to distribute among 3 children A, B and C. A should get 2 toys, 3 toys and 5 toys. So obviously it is OP, na? Order partition, because I have said 3 children. So what will be our answer? 10 factorial, 2 factorial, 3 factorial, 5 factorial. Same answer I am getting. Why same answer? Because there is no repetition here. If there was repetition, then we have to divide by that much factorial also. So here by chance OP and UOP both are giving us same answer. Okay, because of no repetition. So same answer because of no repetition. Because of no repetition. Okay. Please take snapshot. I will jump to the next slide now. I think there is no doubt. It's clear.
Yes, sir.
Okay. So next is, so we have 30 persons and make 2 teams of 11 persons each. How many ways are there? So we have 30 persons, okay, and we want to make 2 teams of 11 persons each. So how many ways are there? So first question is it UOP question or OP question? That is the first, that is the basic thing which we should understand. So we have 30 persons and we want to make 2 teams. So see, we are not labeling na team 1, team 2 and so on. So obviously it is UOP case. Okay, yes. So now what I am saying, 30 persons and make 2 teams of 11 persons each. So you want to pick 22 persons. Na? So from 30 persons, you have to first pick 22 persons. You have picked 22 persons from 30 persons. So now you have 22 persons and now you want to make 2 teams of 11 each. So what will be our answer? Multiplied by 22 factorial, 11 factorial, 11 factorial. Okay, and multiplied by 2 factorial. Why? Because same, that's why 2 factorial. So this is my answer. So just one step more. So this question is just one step more. Why one step more? Because 30 persons were there. So first is you have to pick 22 persons. So you have picked the 22 persons, or you can say choose 22 persons. So now since you have chosen 22 persons, so now everything is fine. So 22 persons are there. You have to make 2 teams of 11, 11 each. So simply UOP. So you will simply do it. So 22 factorial divided by 11 factorial, 11 factorial into 2 factorial. That's it. So I hope it's clear. Please take snapshot. I will jump to the next slide. Okay. Next is, so finally 9 categories of problems. I'm repeating again and again. 6 categories B and C over. 7th category, that is distribution. This is also over. Yeah, and I think one more is left, identical to identical. Let me show you that also. So one category is left now, identical to identical. Okay, see this. If you have, let me just do it. Distinct to distinct, OP, order partition. We have done. Distinct to identical, UOP. Only one category was there. Here we have done 3 categories. Here we have done only one category, that is fully specified. So what were the 3 categories here? Fully specified, partially specified, or unspecified. But here only one category, that is fully specified. Okay, identical to distinct, we have already done it. Formula was n minus 1 plus RCR. So only one is left, that is identical to identical. And here in GATE 2022, this year itself, question has been asked. So let me show you. So identical to identical, how we will do it. Okay, so for example, I can say we have say 4 identical balls. 4 identical balls, or you can say distribute 4 identical balls among 3 identical you can say boxes. How many ways? So you have to understand this word identical. Okay, if this word identical is missing, by default, I have told you many times, you have to take distinct. By default, if nothing is given, by default you will take distinct. Nothing is given, but they are saying properly, distribute 4 identical balls, all the balls are identical among 3 identical boxes. If here identical word was missing, so you will say 4 identical balls among 3 boxes, so you will simply apply n minus 1 plus rcr and you will solve and get the answer. And this was done by many students in GATE exam in GATE 2022, and they have got the wrong answer. Okay, they just skip this word identical. Okay, so here identical word is properly given. Okay, so what we should do now? So let me tell you. So now I cannot say na box 1, box 2, box 3 because they are identical. Okay, and balls are also identical. So I will say like this. So but I'm labeling them just because I can show you the things. So what I will say, you have to do each and everything manually. For example, you will say 004. Okay, now please do not say 040 or 400. They are same only. So you will just apply this way, 004. Another can be, so first way is this, give all the 4 balls to one of the box. That is the way. Another can be 0 2 031. Okay, so 3 to 1, 3 balls to 1 box, 1 ball to 1 box. Now please do not say 310 or 130. They are same only. Okay, yes. So you have to count it manually. There is no way out. This is that is the beauty of GATE exam. They will ask you such questions and they just want to check your analytical skills. If you have done formula, many students, almost 99.9% students have done like this. And unfortunately, even on YouTube, if you will search that GATE 2022 question, many even mathematics teachers have solved like this only. But in YouTube, I have already made the video, and many students appreciated me for this thing, that you have done this category, and same question have been asked in GATE exam. Okay, so this is all about experience, na. So I have whatever predictions I have made, I have done prediction in say 2012. Okay, and the same question have been asked in say at most 2016 or 2017. That is the beauty of experience. So I keep on doing predictions and all, like this is important, that is important, and someday or other that question have been asked in GATE exam. Okay, and many this is the beauty, many teachers have solved like this way. They just ignore this word identical. Okay, yes. So finally, yes. So finally, so for next way, 004, 031, 022. Okay, so this is regarding 0. Okay, and what other ways can be done? 1 2 1. Okay, yes. Any other way? 4 is given to all the 4 in one box, 3 in one box, 1 in one box, 2 and 2, and 1 1 2. I think there is no way out. Any other way? I think there is no other way, no?
Yes, sir.
That's it. So only 4 ways. Only 4 ways. Okay. Yes, and the things will be big. If we say 10 identical, I think this was the question. 10 identical balls and 3 identical boxes. How many ways? So box 1, box 2, box 3, 0 0 10. That's it. 0 9 1. That's it. 0 8 2. Then 0 7 3. It will be big. It will be big. I think so. So I think that was not the question. The small question was there. Okay, and then 0 7 3, and then 6 4, then 5 5. Okay, yeah, that's it. Now you cannot say 0 4 6 because you have done it. This way you have done it. Okay, so this is over. So now what we will say, now you will apply 1 here. Now 9 are left. So for 9 you can take 1 8, okay, or 2 7, or
109.
yeah 0 9 0 9. Yes, but 109, no, we will not give 109 because this is there.
All right, sir.
So 0 now I will not consider 0 now. Okay, that's why I'm doing 1 now.
Yes,
So 1 to 7, then 1 3 6 1 4 5. That's it. Now 154 we will not say 154.
Yes,
Okay, and
yes.
then we will jump to 2. Then 2, then how many are left? 8 are left now. So 8 minimum, I will give 1 here and 7 here. 217. Please check 217. Yes, we have done it. So I will not do it again. This is repetition. Like this, you have to check. Okay,
Yeah.
so
2, 3,
2,
5.
then 2 2. Okay, I have done 217. Then 2 2 6. Then 2 3
5.
and 5.
5, sir.
2 3 5. 2 3 5 I have done.
No, sir.
No. Yes. So then 2 4 4.
Yes,
Okay.
sir.
So like this. So then we will shift to 3. Okay, and then with 3, what I will say, 3, then 7 are left now. So 7 will be 1 and 6. 3 1 6. So we have done. Yeah, we
1, 6.
have done it. 1 3 6 we have done. So I will not take it. So
3, 3,
3
4.
3 to 5. 3 to 5 we have done. We have taken it. 3 to 5
3, 3,
also.
4 will take, sir.
Hmm.
3, 3, 4.
3 3 4. Yes, 3 3 4 we will take it. Like this, I think you have got it. The way we will.
Yes, sir.
Yeah, so I should leave it. Okay, so I should not waste time here. So basic idea you have got it. The basic thing is you have to do manually. That is the basic thing. Okay, and many times question have been asked like this, so that they just want to check your analytical skills. That's it. Okay, so please take snapshot. I will jump to the next slide now. Identical to identical is over. Next, I'm jumping. So dot dot dot. I'm applying dot 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 because you will check other possibilities.
Yes, sir.
Yes. So next is, so 7th category of distribution problem is over. So now we will start 8th category, that is principle of inclusion exclusion. 7th category is now over. 6th categories PNC are also over. 8th category, that is principle of inclusion exclusion. Let me start that. So I will jump to the next slide. So principle of inclusion exclusion, what it is saying, so I think you already know. Okay, Venn diagram, A union B. What is the number of A union B is A plus B minus A intersection B. Because if you have done A B, then you have counted this part twice, so you will subtract 1 time, you will get the answer. I think I should not explain these things. These are very basic thing.
Yes, sir.
Yeah. So now yes. So I will simply give you the wordings. A union B means A or B. A or B. Okay, and A XOR B means either A or B but not both. Either A or B but not both. And how XOR is fine? A B minus 2 times A intersection B. A XOR B means what? Either A or B but not both. So you want to find this thing and this thing. Okay, so obviously this common part should not be taken, na? So when you will say A, common part is taken. When you say B, common part is also taken. So I will subtract 2 times, so that common part is gone totally. So finally you will get this as your answer. Next is A minus B. A minus B means A but not B. A but not B. So how you will find A minus B? A but not B. So you will take total A and you will subtract A intersection B. So finally you will get this thing. So A minus A intersection B is my answer. So you here, this is the way you will find A minus B. B minus A, same, B minus A intersection B. When you will take B, you will get entire thing, and you just subtract the common part, you will get only B. Okay, are you getting it now? A but not B. Similarly here, B but not A. Okay, next is A complement intersection B complement. This means what? Neither A nor B. This means neither A nor B. Okay, so how you will find this? So A bar intersection B bar. You just change it into logic style. A bar B bar. So it is nothing but A plus B bar. So A plus B means A union B. Bar means what? Subtract it from universal set. So U minus A union B. Universal set minus A union B. That will be A complement intersection B complement. And how you will find A complement union B complement? It means what? It means either not A or not B. This means either not A or not B. So same scenario. So A bar plus B bar. I have just converted it into Boolean algebra style. A bar plus B bar. So you will say what? AB bar. AB bar. So AB means what? A intersection B. Bar means what? Subtracted from universal set. So finally you will get it. So yes. Take snapshot. And now I will jump to the questions. How questions will be asked from this thing.
Done, sir.
Okay. So the first question. How many 8-bit numbers start with 0 or end with double 1? 8-bit numbers start with 0 and end with double 1. Start with 0. First of all, you have to find A. A is start with 0. So 8-bit number start with 0. So this is 0. Bit means what? 0 or 1. Na? So here two possibilities 0 or 1. Here two possibilities 0 or 1. That's it. So here only one possibility. Rest everywhere two possibilities. So 8-bit. So 2 power 7. I think you have got it. A is this. B and with double 1. And with double 1 means what? So everywhere I am having two possibilities 0 or 1, 0 or 1. So 2, 2, 2, 2. But at the last place I will be having only one possibility. Why? Because I want to end them by 1. Are you getting it? 1, 2, 3, 4, 5, 6, 7 and 8. Yes. So that's it. So how many ways are there? 2 power 6 ways are there. So A is this, B is this. So what I have said, start with 0 or end with double 1. So A intersection B I have to find. A intersection B will be what? Start with 0 and end with double 1. Start with 0 and end with double 1. Start with 0 and end with double 1. So total 5. I think 2 power 5 na. So here two possibility either 0 or 1. Here also two possibilities 0 or 1. So here and here. So 5. And here only one possibility, and here also one possibility. Please do not think it as 0. This is one possibility because here 0 will be there. Here one possibility because of 1. Here one possibility because of 1. So 2 power 5. These are very simple things. Okay, you can do it in your mind also. Okay, these are very basic things. So 2 power 5. So what will be our answer? What they are asking? Start with 0 or end with double 1. A union B, like this they want to ask. So A plus B minus A intersection B. So A is what? 2 power 7. 2 power 7. B is what? B is 2 power 6 minus A intersection B 2 power 5. Final answer. And please try to focus here. Please do not think that start with 0 and with double 1. So 2 power 7 plus 2 power 6. Why I am subtracting 2 power 5? Because in 2 power 7 I have taken the possibility of ending with double 1. And in 2 power 6 I have taken the possibility of starting with 0. So obviously I have counted them twice. So I have to subtract one time. That's why I have subtracted 2 power 5. Okay. So I think you have got it.
Yes, sir.
But if anybody is
before giving the final answer, no, sir?
Yeah. So simplification is very simple. 2 power 7 is what? 128. 2 power 6 is 64.
Yes,
and 2 power 5 is 32. This is my answer. Okay, so start with 0 or see if you find any or and this kind of thing. So you will say that okay, it is principle of inclusion exclusion question. Okay, yes. So let me jump to the next slide now. Okay, so the next question is start with 0 or end with double 1 but not both. So but not both means what? They want to ask A, X or P like this. So it will be A, B minus 2 times of A intersection B. So A we have already find 2 power 6, B 2 power 5 and 2 power 7 was A. Sorry for that. 2 power 7 plus 2 power 6 minus 2 multiplied by 2 power 5. So clearly 2 power 7 will be my answer. These two will be cancelled out. Na? Are you getting it? 2 into 2 power 5 is nothing but 2 power 6 only. Let me write 2 power 6 minus 2 power 6. So the answer is 128. Yes. If you have any doubt, please let me know.
Yes, sir.
No, sir. Clear, sir.
Okay. Question number 3, start with 0 but does not end with double one. So we want to find A minus B this. So this is what A minus A intersection B. A is 2 power 7 and A intersection B is 2 power 5. We have already find. So this is my answer, 128 minus 32. And it comes out to be 96. Let me jump to the next slide.
Yes, sir.
Next is end with double one but does not start with 0. It should end with double one but it does not start with 0. So we want to find B minus A. So B minus A intersection B. End with double one. Answer was 2 power 6. Okay, because end with double one means what? Last 2 bits are reserved for 1. But 6 bits, first 6 bits have 2 possibilities. So 2 power 6 minus A intersection B. Start with 0 and end with double one. 2 power 5. So it comes out to be 2 power 6 is 64 minus 32. It comes out to be 32 as answer. And in GATE exam, let me tell you a very small trick. So you can do like this also. 2 into 2 power 5 minus 2 power 5. So 2x minus x is nothing but x only. So 2 power 5 will be the answer. That is 32. So you can do like this also. Okay, let me jump to the next slide. Neither start with 0 nor end with double one. So it will be A complement union B complement like this. So it will be nothing but universal set minus A union B like this. Universal set is what? No restriction, 8-bit numbers. So 2 power 8. Everywhere 2 to possibility. So 2 power 8 minus A union B. A union B we have find out. So 2 power 7 plus 2 power 6 minus 2 power 5. Okay. Yes, so I think we can solve and get the answer. Let me jump to the next slide now.
Yes, sir.
Next is either not start with 0 or not end with double one. A complement union B complement we want to find. That will be universal set minus A intersection B complement. A intersection B. Universal set is 2 power 8. A intersection B was 2 power 5. This is my answer. So how to do it fastly? You will say like this: 2 power 3 multiplied by 2 power 5 minus 2 power 5. So 2 power 3 is 8. 8 into 2 power 5 minus 2 power 5. So 8x minus x, that is 7x. So 7 into 2 power 5. So 7 into 2 power 5 is 32. So 7 to the 14th, 22, 224 is my answer. Okay.
Yes, sir.
So please take snapshot. I will jump to the next slide now. Okay. So the next is we will start now 3 elements. We have done till 2 elements. Now we will start 3 elements. So A, B, and C. These 3 are there. So A union B union C is what? That is A plus B plus C minus A intersection B minus B intersection C minus A intersection C plus A intersection B intersection C. So the basic rule is odd you have to add and even you have to subtract. Okay, so this is odd, na? 1 is odd, so added. So 2 is even, so you have subtracted. 3 is odd, so you have added. This is the basic rule. Okay, so now you can extend 4 element, 5 element, and so on. Okay, so the basic rule is odd you add, even you subtract. Okay, so now let me solve few more questions. So let me jump to the next slide now.
That's it.
So from 1 to 100, so this is the basic rule which you should remember. From 1 to 100 means 1 and 100 are included. Okay, from 1 to 100 numbers means 1 and 100 are included. Whenever we say between 1 and 100, then 1 and 100 are excluded. They are not there. So that means what? From 2 to 99. So from 2 to 99 you will consider. 1 and 100 are not taken whenever we say between, and whenever we say from, then 1 and 100 are always included. I think you have got it. So now see the question. So these are the very small tips and tricks which you should remember, because they will confuse you in GATE exam. Okay, so this is basic concept. Now we will start the question. So the first question is, how many numbers from 1 to 100 are divisible by 2, 3 or 5? So for this you in aptitude and all you have studied, you might have studied. So let me tell you this, from 1 to 100 how many numbers are divisible by 2? So you will say how many numbers are there from 1 to 100? 100 numbers are there. And why they are 100? 100 minus 1 plus 1, upper bound minus lower bound plus 1. So these are 100 numbers only. If you have any confusion, then you will say from 1 to 3 how many numbers are there? 1, 2 and 3. So there are only 3 numbers. So how you have calculated 3 number? 3 minus 1 plus 1. Okay, upper bound minus lower bound plus 1. So similarly 100 minus 1 plus 1, that is 100. So plus 1 minus 1 is confusion. Many students get confused here. So 1 to 100 how many numbers are there? 99 or 100 or 101? That is the confusion. So 100 is the answer. So if you are getting confused that why 100 is the answer, you take small number. From 1 to 3 how many numbers are there? You will say 1, 2 and 3. Count, no? Count on your finger. 1, 2 and 3. So 3 numbers are there. So that means for 3 minus 1 plus 1, that is my answer. So similarly 100 minus 1 plus 1, 100 is my answer. Like this you can do in GATE exam in real time basis. If you have any confusion, do like this in real time basis. Okay, so 100 numbers are there. So how many numbers are divisible by 2? So you will say 100 divided by 2, floor function is my answer. That is nothing but 50. Okay, and I'm not going into proof and all because it will simply waste our time. You will study these things in aptitude. So next is number divisible by 3. So I will take it as A. A is this. B, number from 1 to 100 divisible by 3, 100 by 3, floor function, that will be 33. B is 33. C, how many numbers from 1 to 100 divisible by 5? 100 by 5, floor function, that is 20. Okay, so we have find out A, B and C. So now A intersection B, A intersection B. What is this? Number divisible by 2 and 3. So 2 and 3 is 6. So you will take floor function. Okay, so you have to take LCM. Okay, if we say divisible by 2 and 3, so you will take LCM of 2 and 3. LCM of 2 and 3, that will be 6. So A intersection B, 100 divided by 100 by 6, floor function, and it comes out to be what? 6 1 the 6. So 6 2s are 12. No. A 7. 7 is the 42. I think 17 is the answer, or 16 is the answer. 16 6 the 96. Sorry, 16 aega. Yes, 16. Okay, A intersection B will be 16. Now B intersection C. B intersection C. 3 and 5 LCM will be 15. 100 by 15. 50 is 6. It will be 6. Okay, A intersection C, because 15 7s are 105, na? It will be more. So 6. So A intersection C, 2 and 5, that is 10. LCM of 2 and 5 is 10. So floor function, it will be 10. Okay, and then A intersection B intersection C. A intersection B intersection C. So divisible by 2, 3 and 5. 5 is the 15. 15 into 2, 30. 100 by 30, floor function, it will be 3. So now I think it's very easy for us. So final answer will be what? A plus B plus C, these will be minus and this will be plus. So final answer will be 50 plus 33 plus 20 minus 16 minus 6 minus 10 plus 3. Solve and get the answer. Okay, yes. So next is okay, take snapshot. I will jump to the next slide now.
That's all.
Next is exactly 1 of 2, 3 or 5. How many numbers from 1 to 100 are divisible by exactly 1 of the 2, 3 or 5? So they want to ask this question, A XOR B XOR C, like this. Exactly 1, na? When we say exactly 1, see, A XOR B means what? Exactly 1 of. I can write like this also. Here, either A or B but not both. So indirectly this means what? Either A or B but not both. That means what? Exactly 1 of A or B. Exactly 1 of A or B. One and the same thing. Now please try to understand. Please try to make sense out of it. Either A or B, but not both. That means what? Exactly one of A or B. So same is the case here. So they want to ask, yeah, exactly one of 2, 3, or 5. So that means what? A, X, or B, X, or C. So this you have to remember. I'm not going into proof. So A plus B plus C minus 2 times of A intersection B minus 2 times of B intersection C minus 2 times of A intersection C, and then plus 3 times of A intersection B intersection C. This is the formula. A intersection B intersection C. Proof is not required. Okay. Yes. So now I think we have got everything. We will simply supply the value and get the answer. For A was 50, 33, 20. So 50 plus 33 plus 20 minus 2 multiplied by A intersection B was 16 minus 2 multiplied by, yeah,
6.
please. 6. Okay. Minus 2 multiplied by
10.
कितना था? 10. Okay.
10.
Plus 3 multiplied by 3.
Yes, sir.
Okay. So finally we will get this answer. Okay. So the next question is, please take snapshot. Okay. So yeah, next is none of 2, 3, or 5. None of 2, 3, or 5 is A complement intersection B complement intersection C complement. I think you have got it now. None of A 2, 3, or 5. That means neither A nor B nor C. Okay, we will write like this: none of 2, 3, or 5. So like this. So this is very simple. Universal set minus A union B union C, like this. Okay, so universal is what? 100. All the numbers we have taken 100 minus A union B union C. I think we have find out now. So what was the answer?
We did not, sir. We found out A intersection B intersection C.
No, here we have find this, na?
Sir. Yes, sir. Yes, sir.
Divisible by 2, 3, or 4. Yeah. So you just put this value and get the answer. Okay. Yes. So we can put this value. So from previous slide you can take. I should not write them. 50 plus 33 dot dot dot. I am just leaving it. Okay. So none of 2, 3, or 5. This will be our answer. Okay. So total numbers are 100. From this you have subtracted this. That means what? Divisible by either 2, 3, or 5. Yeah, it was 74.
Yes, sir.
Okay, so final answer will be 26. So 26 are those numbers which are neither divisible by 2, 3, or 5. Okay. Yes. So I think it's very simple. It's common sense. If anybody is having any doubt, then I will try to show you by other methods also. I think it's fine now. It's easy.
Yes, sir.
Yes, sir. It is.
Okay, so I will jump to the next slide. Next is either not divisible by 2 or not 3 or not 5. So this means what? A complement union B complement union C complement. So that will be what? Universal set minus A intersection B intersection C. By I have just applied De Morgan's law. So 100 minus 100 divided by 30 floor function. So it comes out to be 100 minus 3, that is 97. Very simple. Let me jump to the next slide. Next is divisible by 4 or divisible by 6. Numbers are 1 to 100. Just to save the time, I have written this type of questions. Okay. So divisible by 4 or divisible by 3. How many numbers are divisible by 4 or 6? From 1 to 100 we have to take up. So same, A union B, it will be A plus B minus A intersection B. There is a very small twist in it. So 100 by 4 floor function plus 100 by 6 floor function minus 100 by, many of you will do 6 into 4 24, but no, I have used the word LCM. So 6 and 4 LCM will be 12. So you have to write like this. This was the very small twist. That's it. So rest everything is fine. So let me write it properly. You will do like this. This is wrong. So I have to write 100 by 12. This is correct. Okay, yes. So solve and get the answer, please. So let me jump to the next slide. Please take snapshot. Okay, so sometimes they will say, so the key idea is LCM. Key idea is LCM. Okay. Yes. Next is from 100 to 1000, how many numbers are divisible by 2 or 3? That is a beautiful question. So how you will approach such type of question? So from I want to calculate from 100 to 1000. So now if I say from 1 to 1000, that is very easy. You will simply say 1000 divided by 2 floor function plus 1000 divided by 3 floor function minus 1000 divided by 6 floor function. From 1 to 1000 was easy. But 100 to 1000, how we will do? It is very easy. So we will calculate from 1 to 1000. Okay, and then we will subtract how many? 100 I have to take na. So 1 to 99 I will take. So I will subtract 1 to 99. I am not subtracting 1 to 100 because 100 I have to take. That's why. So from 1 to 99 you will subtract. So this is for 1 to 1000. Now 1 to 99 I think we can easily do it. So 99 by 2 floor function plus 99 by 3 floor function minus 99 by 6 floor function. That's it. Okay, why 6? Because LCM 2 and 3 is 6. That's why. So this is my answer. So minus this.
Yes,
So
sir.
you will apply brackets properly. That's it. Please take snapshot. I will jump to the next slide.
Done, sir.
Okay. So now we will start derangements. This is very important. Many times question have been asked. So what exactly derangement is saying? See, for example, you have a black box and a black ball, red box and a red ball, blue box and a blue ball. And what I am saying, none of the ball get the correct place. That is the beauty here. None of the ball should be at the correct place. Correct place means what? Black should go to black, red should go to red, blue should go to blue. So what now I want to say? I want to say none of them should go to the correct place. Like black go to red, red go to blue, okay, and this blue goes to black, like this. Are you getting it? So like this you have to do. So how many ways are there? That is known as derangement. Arrangement means you want to arrange something. Derangement means opposite of it. So none of them should be at the correct place. Similarly, another question can be, we have 5 CPUs and 5 CPU slots. So none of the CPU go to the correct slot. That is the basic thing. So many of you will answer, sir, 5 factorial ways will be there, 5 CPUs and 5 slots. So 5 factorial ways we can arrange them, and minus 1 you will do because all of them will be at the correct place. That will be 1. So 5 factorial minus 1, that is correct. No, it means at least one of the CPU is at wrong place. Okay, please try to follow this. What I am saying here, none of the CPU go to correct place, but 5 factorial means total ways, and 1 means all are correct. All are at correct place. There is only one way, na, when all will be at correct place. So when I will subtract 5 factorial minus 1, it will say at least one at incorrect place. This means at least one CPU at incorrect place. But what exactly I want? None of the CPU go to the correct slot or correct place. Okay, each and every CPU should be at the wrong place. That is the basic thing. This is known as derangement. So like here, I will say each and every ball at wrong place. That means a basic thing, none of the ball at the correct place. Okay, I am not saying that at least one of the ball at wrong place. No, I am saying each and every ball at wrong place. That is the derangement. Now please take snapshot. I will jump to the next slide and I will show you how to do all these things.
Done, sir.
Okay, so I will say like this. So I will define the events A, B, C, D, E. A is first CPU at the correct place. So A event means first CPU at correct place and forget about all others. B, C, D, E, 4 CPUs are left. 4 CPUs, it hardly matters to me. They go to correct place, wrong place, it hardly matters to me. My concentration is at only first CPU. It should be at correct place. That is the basic meaning of event A. Event B means second CPU is at correct place, forget about others. Similarly, C means third CPU at correct place, forget about others. D means fourth CPU at correct place, forget about others. E means fifth CPU at correct place, forget about others. That is the basic thing. Okay, so now what I want to find? I want to find A should be at incorrect place, and B should be at incorrect place, and C should be at incorrect place, and D should be at incorrect place, and E should be at incorrect place. And I want to find this thing. So this will be clearly what? Universal set minus this thing. So this means what? Either A is at correct place, or B, or C, or D, or E. So now the basic thing is universal. We already know 5 factorial. Universal is very simple, 5 factorial minus this thing I had to do. Now this is very you can say tedious task. Why? Because I have to do you can say for 5 sets I have to do union. Okay, that is difficult task. So now let me explain you how we will do it. Let me jump to the next slide and I will show you. Okay, please take snapshot.
Yes.
Okay, so now I will do it you can say step by step. First is number of terms in this. Can you guess how many terms will be there? So I will say like this, 5 na. So choose one, 5C1. That means what? A plus B plus C plus D plus E, like this. So total 5 terms will be there, 5C1. Then 5C2 will be there. Why? Because 2 2, you will pick 2 2. Then 5C3, then 5C4, and then 5C5. Are you getting it?
Yes, sir.
So 5C1 means A, B, C, D, E. 5C2 means 2 2. A, B, A intersection B, A intersection C, A intersection D, A intersection E, and so on. Like this. And then 5C3, 5C4, 5C5. So what will be our answer? If you try to remember 5C0 plus 5C1, I have told you many times this identity. 5C2, 5C3, 5C4 plus 5C5. That is nothing but 2 power 5. Yeah, 32. Very good, 32. So now I just want to subtract 5C0. 5C0 is nothing but 1 only. So what will be our answer? 31. So total 31 terms will be there. 32 minus 1, that is 31. So 31 is the answer. So 31 terms, that is next to impossible to write and all. So what is the shortcut? Let me tell you this thing. Let me jump to the next slide now. Yes. Okay, you have taken the snapshot now?
Yes, sir.
Yes, sir.
So okay, so now I want to, okay, for before generalization, let me tell you here itself, because I do not I have not taken any other you can say slide. So let me tell you here itself. So what should be done now? So 5C1 terms means what? A. So if I say this will be what? A you can say 5C1 is A plus B plus C plus D plus E. The beauty is all of them, their modulus will be same, or you can say their number will be same. Why? I will say first CPU is at correct place. A means what? First CPU is at correct place. So forget about others. How many are left? 4 are left. So I will simply say there are, see this, these are the 5 boxes, 1 2 3 4 5, or 5 slots, and these are the 5 CPUs, 1 2 3 4 and 5. I am saying 1 is at the correct place, and 2 3 4 5 are left, and there are 4 slots. Same, 4 persons, 4 chairs. How many ways to sit? 4 factorial. So simply I will say answer will be 4 factorial for this. Okay, so 5C1. So I will write like this. So 5C1 multiplied by 4 factorial. Are you getting it? Plus then 5C2. So I will say 5C2. 5C2 means what? A and B at correct place. That means I will say like this. Either 1 and 2 are at correct place, or 1 and 3, 1 and 4, 1 and 5, and so on. So what I forget about others. I will not say about others. I will simply say 1 and 2 are at correct place. So 1 and 2 are at correct place. So I will say I am left with only 3, 3, 4 and 5. So at 3 persons and 3 chairs, how many ways? 3 factorial. So I will simply say 5C2 into 3 factorial. And I will subtract it. I will not add it. Why I am subtracting? Because you already know A union B union C. So even are subtracted, odd are added. I have told you, na? That's why I will subtract it. Now next will be odd, 5C3. So I think you have got it, multiplied by 2 factorial. Because 3 will be at the correct place, 2 there will be choices for them. So 2 factorial ways. Then minus 5C4, because even minus 5C4 multiplied by 1 factorial. Okay, and then plus 5c5 multiplied by 0 factorial. Are you getting it?
Yes, sir.
Yes. So this is the way to do, and this is what A union B union C union D union E. We have got this thing, and total was what? 5 factorial was total. So this will give us D arrangement answer. Are you getting it? So 5 factorial is the total ways. 5 CPU, 5 slots, total ways 5 factorial minus this thing. Either A is at correct place or B or C or D or E. So this means what? From total I have subtracted this. That means what? None will be at the correct place, and that will be our D arrangement answer. So how we will solve it? So I will simply say 5 factorial is, okay, first let me solve it, then we will generalize. Don't worry. So 120. 120 minus 5c1 into 4 factorial. 5 into 4 factorial, that is nothing but 5 factorial only. It will be 120 minus 5c2 into 3 factorial. It will be 10 into 5c2 is 10, na? 10 into
Yes,
6,
sir.
that is 60, plus 5c3 and 5c2 are same. It will be 20 minus 5c4 and 5c1 are same, 5 plus 1. So 120 120 got cancelled. So 60 minus 20 plus 5 minus 1, it comes out to be 44. Please have a look on it, and if you have any doubt, please ask me.
Yes, sir.
Yes. Okay. Snapshot taken.
Yes, sir.
Yes, sir.
Okay, now we will generalize. Generalize n CPU n slots. So how we will generalize? So total ways are n factorial ways minus. So now please try to focus. So n slots, na? N CPU n slots. So one of the CPU is at correct place. So I will say from n terms you will pick one term, nc1, multiplied by 1 is at correct place. So rest n minus 1 CPUs are left. So all of so it will be n minus 1 factorial. Are you getting it? N minus 1 CPUs and n minus 1 slots. So randomly you can place anything anywhere. So n minus 1 factorial. Then since it is odd term that was added, so even terms it will be subtracted. nc2 multiplied by n minus 2 factorial plus nc3 multiplied by n minus 3 factorial. Then minus nc4 multiplied by n minus 4 factorial. Are you getting it? So we will keep on doing like this till what we will get ncn multiplied by 0 factorial. And this ncn terms will be plus or minus, it depends. It depends on the n. Okay, so if n is odd, then it will be plus. If n is even, then obviously it will be minus. So simple. Are you getting it? Now see, odd is added, even is subtracted. Odd is added, even is subtracted. So if this n is odd, then obviously it will be added, and if this n is even, then it will be subtracted. Okay, so 0 factorial is already 1, no problem. So simply it will be plus 1 or minus 1. So it will depends on either n is odd or even. If n is odd, it will be plus 1. If n is even, it will be minus 1. That's it. Okay, so now what we will say, now I will try to open it up. So I will say n factorial. I think you have got it. This and this will be cancelled out. Why? nc1 is n multiplied by n minus 1 factorial, that will be n factorial only. So this and this will be cancelled out. And what finally we will left out with, so here we are having minus now, and here we have minus, so it will become plus. So nc2 n minus 2 factorial. Okay, so and if we open it up more precisely, let me open it up. nc2 means what? N into n minus 1 by 2 multiplied by n minus 2 factorial. So n into n minus 1 into n minus 2 factorial, it will be n factorial only. So finally what I will get, n factorial by 2. Are you getting it?
Yes, sir.
Yes,
Then
sir.
here we were having minus, and here I am having plus, so finally it will be minus. So nc3, now I think n into n minus 1 into n minus 2 divided by 3 factorial or n minus 3 factorial. Here we have multiplied. So finally what we will get here? N factorial again divided by 3 factorial. So n factorial divided by 3 factorial. Here I should write like this. 2 and 2 factorial are one and the same thing, but I am writing it properly so that we can make a formula. N factorial divided by 2 factorial minus n factorial divided by 3 factorial plus, because minus here and here minus, it will be plus. So I think you have got it. N factorial divided by 4 factorial. Okay. So same way we will keep on doing it, and then minus n factorial divided by 5 factorial dot 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 n factorial divided by n factorial. So this will be added or subtracted, it entirely depends. If it is even, now I will say opposite. If it is even, then added. If it is odd, then it will be minus. Why? Because here was minus, na? That's why. So yeah. So finally we will get this as our answer. Okay. So this is our answer, and if I want to condense it more, then what I will say for dn. Dn means for n arrangements. This formula has been asked in GATE, by the way. So for r is equal to 2 to n minus 1 power r n factorial divided by r factorial. Please try to see this. R is equal to 2, then it will be positive. N factorial divided by 2 factorial. Then R will be 3. So it will be minus 1 power 3, that will be minus 1, and n factorial divided by 3 factorial. Then plus n factorial divided by 4 factorial, and so on. So this is the formula for derangement. Okay, please take snapshot. I will jump to the next slide now.
Yes.
Okay. So yeah, so next is, so now we will solve few questions. So 5 balls and 5 boxes, none of the ball go to the correct place. Simply, clearly you will get the hint in GATE exam. They will never ask direct question. How many derangements are possible and all? They will ask questions like this. 5 balls and 5 boxes, none of the ball go to the correct box. So simply you want to find d5. d5 means what? 5 factorial divided by 2 factorial, then 5 factorial divided by 3 factorial, then 5 factorial divided by 4 factorial, then 5 factorial divided by 5 factorial. This is my answer. It's very simple. So you will go till you will get answer as 1. That's it. Okay. So 2 plus 2 minus 3 plus 4 minus 5, and so on. You will keep on doing it till you will get what? Finally you will solve it and get the answer. That is the beauty. So next is equation. How many jumble words of equation such that none of the letter at correct place? Same derangement only. None of the letter at correct place means what? E is at first place, Q is at second place, U is at third place, and so on. So none of them is at correct place. Now please see here, there is no repetition. If repetition is there, then it is really very difficult. Anyway, GATE question have been asked on repetition only. I will come to it after few slides. So please focus here. There is no repetition. There is no repetition. Okay, equation what? There is no repetition. No repetition of letter. And 8 letters are there. So none of them is at correct place. That means what? E should not come at first place. Q should not come as second place. U should not come at third place, and so on like this. So none of them at correct place. So I think you have got it. This is nothing but your D8 only. D8 will be what? 8 factorial divided by 2 factorial. Then minus 8 factorial divided by 3 factorial plus 8 factorial divided by 4 factorial minus 8 factorial divided by 5 factorial plus 8 factorial divided by 6 factorial minus 8 factorial divided by 7 factorial plus 8 factorial divided by 8 factorial. Answer. Very simple. Okay. Take snapshot. I will jump to the next slide.
Answer.
Okay. So next is 5 CPU, 5 slots. So now these type of questions are very basic. All at correct place. How many ways are there? 5 CPU, 5 slots. Only one way, na? All are at correct place. Okay, so only one way will be there. Okay, I think I should not explain it. This is very simple. Next is none at correct place. That is nothing but your derangement only. Derangement. Okay, and that is nothing but your D5. And D5 I think we have solved. 44 was our answer. At least one at incorrect place. At least one at incorrect place. So total is what? 5 factorial ways. At least one. So all at correct place minus 1. So that is nothing but at least one at incorrect place. So 5 factorial minus 1, that is 199 is, sorry, 119. 119 is my answer. 5 factorial is 120. Na? Are you getting it? At least one at incorrect place. So total is 5 factorial and all at correct place. You subtract it, you will get what? At least one at incorrect place. By complement method, I have solved it.
So
Okay.
it is 1 minus 5 factorial?
No, 1 minus 5 factorial will be negative answer. How we can have negative?
Okay. Now at least one at incorrect place. All at correct place is 1.
All at correct place. And 5 factorial is what? Universal. That means no all possible arrangements. All arrangements.
Yes.
So from all arrangements, I will subtract all at correct place. So what I will get? At least one at incorrect place. Is it making any sense? Try to again read it. All arrangements, all possible arrangements. And I am subtracting what? All are correct. So what I will get? At least one is incorrect. Na?
Sir.
That's it. Okay, last is at least one at correct place. Okay, what is this? At least one at correct place. So that is nothing but your this thing only. A union B union C union D union E, which we have done already. At least one at correct place. So from total we have subtracted, then we will get derangement. So finally from derangement, if I will subtract from total, if I will subtract derangement, I will get this only. So 5 factorial minus D5 is my answer. Are you getting it?
Yes,
D5 is what? So that's it. Yes. So fourth question, generalized formula is this. For fourth question, at least one at correct place. So n factorial minus derangement for n. Okay, that is generalized formula for at least one at correct place. Is it okay?
Yes, sir.
Okay, so let me jump to the next slide now. Okay, so question number 5, exactly one CPU at correct place. Again, this type of questions are very beautiful and very common. Exactly one CPU is at correct place. So which CPU is at correct place, I do not know. So first I have to choose 5C1. From 5 I will choose the one CPU which will be at correct place. So rest 4 there is no problem at all. But rather what I have said, exactly one CPU at correct place. So rest 4 should be at incorrect. All should be at incorrect places. Na? So finally I will multiply it by D4. Derangement for 4. Are you getting it? Exactly one CPU is at correct place. So 5C1 means what? So which one is at correct place? I do not know. Na? So I will choose one CPU and I will say it is at correct place, and rest other 4 they should be at incorrect places. All should be at incorrect places. That is nothing but your derangement only. So 5C1 multiplied by D4. D4 I think it is very easy to find. So 5C1 is 5 only, and D4 is nothing but your 4 factorial divided by 2 factorial minus 4 factorial divided by 3 factorial plus 4 factorial divided by 4 factorial. So please solve and get the answer. So generalize, if I want to generalize, so generalized formula is very simple. NC1 multiplied by Dn minus 1. That's it. So let me jump to the next slide now. So this is a gate question. Okay, this type of question I was talking about, that because there is a duplicacy here, so there is no way out. As soon as you see duplicacy, you have to do manually. So lilac is a word. How many jumble words so that none is at its original place? So many students will you can say okay, none is at correct place. Derangement means 5, so D5 is the answer. Okay, that's why I am repeating again and again, do not by heart anything. So D5 is the answer, but no, D5 is not the answer. Why? Because there is a repetition here. So the only way is you have to do manually. So how you will do manually? So L is creating problem now, because L is, we are getting L 2 times. So let me write it 5 S's. So L should not be first place, it should not be third place. So L, and here we can have L. This is one possibility. What are the other possibility? 1 and 3 is not allowed. So this and this is allowed. Are you getting it? 1 and 3 is not allowed, na? So this and this and this. Okay. Any other way? Any other way? Yeah, I think there is no other way left. Okay, so only two ways.
Side by side, sir.
This and this.
Last two.
Last two. Yeah, very good. Yes, last two also. Yes, very good. 1, 2, 3, 4, 5. This and this. Yes, and any other way? I think there is no other way, na? 1 and 3 is not allowed. 1 and 3 is not allowed. So 3C2, yes, 3 ways will be there. We have written 3 ways. Are you getting it? You can check it out in GATE exam also. This and this is not allowed. So total 3 places are there and 2 else are there. So 3C2, you have from these 3 places, you have to pick 2 places. So 3C2, 3C2 is nothing but 3C1. 3C1 is 3 ways. So 3 ways we have done. So no need to check further. We have done it. Now we will start doing the things. So L and L are satisfied. So obviously these 3 places are left. So what we will start by saying, see, the possibility is that I and A. For first I'm saying, okay, for first, see, here we were having I and here we were having A. So now I and A cannot come here now, because there is no possibility for I and A to come here. So I and A will go to either here or here or here. So they are free because we want to find D arrangement. None of them should be at correct place. But the problem is C can come here. The moment C come here, I will say no. None of them is not at correct place. So first I have to arrange C. So what is the way to arrange C? Either C can come here or C can come here. If I take C to be here, then we will get 2 possibilities. And if I take C here, then again I will get 2 possibilities. Please let me know if anybody is having any doubt here. By 2 possibilities. Are you getting it now?
Yes, sir.
Yes, sir. So okay, so total 4 possibilities will come from here. So now L is here and L is here. So where L is second place. So I and C. Now I and C are free. They can go anywhere. The problem is with A. A should not come here. So first of all, I will arrange A. So if I take A here, then I will get 2 possibility. And if I take A where? Here. Last is L, na? Last is L.
Yes.
Okay, this is L. So I can take A here or here. I cannot take A here, na? So yes, if I take A here, so again 2 possibility. So total 4 possibilities from this way. Next is L and L are here. So A and C are free, no problem. With A and C, no problem. I still can create problem. I can come here, but I will not allow I to become here. So only ways I can go here or here. If I go here, we will have 2 choices. If I go here, we will have 2 choices. So 2 plus 2, 4. So total 4 plus 4 plus 4, that is 12 choices are there. Okay, such kind of analytical skills you should develop. Yes, any doubt?
No, sir.
No, sir.
Okay, so let me jump to the next slide now. So now we will start the 9th category, that is the last category, that is pigeonhole principle. PHP pigeonhole principle. So the tagline, this is at least how many. Exactly how many cannot be answered by pigeonhole principle. It will answer such type of question, at least how many. Okay, yes. So let me tell you what exactly is pigeonhole principle. This is very simple. You will laugh that what is this principle. This is saying we have n pigeons and m pigeonholes. So we have say n pigeons, pigeon 1, pigeon 2, ... pigeon n, and we have holes in which pigeons will be kept. So how many holes are there? M holes are there and n pigeons are there. Okay, and we are saying n is greater than m. Number of pigeons are more than holes. So what obvious way you will say? What obviously you will say? You will say at least one hole will have at least 2 pigeons. That is so obvious, na? At least one of the hole. This is guaranteed, na? At least one of the hole will have at least 2 pigeons. Please let me know if anybody is having any doubt. This is very obvious thing.
Understanding, sir.
Okay,
Understood.
so yeah, so number of pigeons are more than number of holes. So obviously, at least one of the hole will have at least two pigeons. Okay, or you can say more than one pigeon in at least one hole. One and the same thing only, and this is known as basic pigeonhole principle. Okay, so at least one hole will have at least two pigeons, or more than one pigeon. You can say both are one and the same thing only. Because greater than equal to 2 means greater than 1 only, one and the same thing, na? Greater than equal to 2 or greater than 1 and the same thing. So at least two pigeons, or you say more than one pigeon, one and the same thing. Okay, and at least one pigeonhole, this is guaranteed that at least one pigeonhole will have at least two pigeons. Okay, I cannot say every pigeonhole is having at most one pigeon. No, I will say at least one pigeonhole will have at least two pigeons. Okay, so if n is greater than m, if pigeons are more than holes, so now can I say every hole at most one pigeon? This is wrong.
Yes.
Okay, yeah, and if I say at least two pigeonhole will have, these are very important points, please try to focus. At least two holes have at least two pigeons. If I am using these statements, now this means by this should be guarantee that it should be the case. At least two holes will have at least two pigeons. No, it is not guaranteed. I can keep all the pigeons in one hole also.
Yes.
If I keep all the pigeons in one hole, then rest all holes will be zero. Only one pigeonhole will having all the pigeons. That is also possible. So if I say at least two holes have at least two pigeons, this is wrong statement. Are you getting it now? So if I am saying like this, it should be guaranteed, but this is not guaranteed that this statement will be true. But in every case, it is not true. Yes, any doubt here?
No, sir.
Okay, yes. So similarly, I can keep like this also. So let me say it. Okay, because after few slides you will get confusion. So if I say 5 pigeons and I'm saying 3 4 pigeonholes, 5 pigeons and 4 pigeonholes. So 1, 2, 3 and 4 pigeonholes and 5 pigeons. I can keep all the 5 pigeons here, no problem. I can keep 3 here, 2 here, no problem. I can keep 2 here, 1 here, 1 here, 1 here, no problem, and so on. So there are lots and lots of ways. So in all the ways, whatever way you take, this is for sure guaranteed statement. At least one hole will have at least two pigeons. Please try to see this. Whatever ways you take, in all the ways, at least one hole will have at least two pigeons. Everywhere it is correct. At least one hole is having at least two pigeons. At least one hole is having at least two pigeons. At least one hole is having at least two pigeons. Everywhere it is correct. Are you getting it? Now that's why this is known as. You may be thinking that it is very obvious statement, but as soon as we will dig deep into it, you will think that no, it is not so obvious. Okay.
Yes, sir.
Okay, now. So let me jump to the next slide. I think I have explained you clearly. Let me jump to the next slide.
Done, sir.
Yes, so these are some applications, like we have 13 persons. So I will say at least 2 persons will have birthday in the same month. If you pick 13 persons from the world, whatever 13 persons you take, I will say it is guaranteed that at least 2 persons will have birthday in the same month. Why? Because there are only 12 months. So you can think like this, these 13 persons are pigeons and these 12 months are pigeonholes. Obviously persons are not pigeons, but I'm just considering them. So 13 persons, you just consider them as pigeons, and 12 months are pigeonholes. So obviously one pigeon, at least one pigeonhole will have at least 2 pigeons by pigeonhole principle. So I will say at least 2 persons will have birthday in the same month. This is guaranteed, 100% guaranteed. Now it's up to you, or it's your luck. You pick 13 persons and all the 13 persons have birthday in the same month. That is also possible. 10 have in same month, 3 have in other months. This is also possible. Whatever way you take, this is for sure guaranteed that at least 2 persons will have birthday in the same month. This is guaranteed statement. Next, 8 persons you take, and I will say at least 2 persons will have birthday on same day of birth. Why 7 days and 8 persons you have taken? So obviously at least 2 persons will have birthday on the same day. Now it's your luck. You pick 8 persons and all the 8 will have birthday on the same day. Like all are born on Sunday. Like all are born on Monday. Like 5 on Sunday, 3 on Monday. So 4 on Sunday, 2 on Monday, and 2 on Thursday. Like this, we can have any possibility. But this is for sure. Whatever possibility you take, this is guaranteed that at least 2 persons will have same day on same day of birth. That is for sure. Next, 5 colors are there, and I want to color 6 bicycles. But I will say at least 2 bicycles will have same color. That is for sure. At least 2 bicycles will have same color. Now it's all up to you. You have 5 colors and you have 6 bicycles. You color all the bicycles by same color. You can do it. You color all the bicycles, say 5 bicycles by one color and 1 bicycle by another color. Like this, you can take any possibility. But whatever possibility you take, it is guaranteed that at least 2 bicycles will have same color. That is for sure. Yes. Is it okay now?
Yes, sir.
Okay. Please take snapshot. I will jump to the next slide now. Okay. Next is advanced pigeonhole principle. What advanced pigeonhole principle is saying, it is saying we have n pigeons and m pigeonholes. Okay. But the condition is that n is greater than m. So basic pigeonhole principle was saying at least 1 pigeonhole will have at least 2 pigeons. But this is advanced, and what this is saying, then at least 1 pigeonhole will have n by m ceiling function pigeons or n minus 1 floor function plus 1 pigeons. This and this is mathematically equal. N by m ceiling function or n minus 1 by m floor function plus 1. They are mathematically equal. You can take any value of n and m, you can prove yourself. These two are equivalent statement. Mathematically, they are same. That's why I'm saying this or this. Okay, proof. Don't worry. In the next slide, I will give you the question, and from that question only, we will give the proof of this advanced pigeonhole principle. So what it is saying, let me read it again. We have n pigeons and we have m pigeonholes such that n is greater than m. So pigeons are more than holes. That is the basic thing. And then I will say at least 1 pigeonhole will have n by m ceiling function pigeons. Let me show you. Okay, please take snapshot. Yes. So now I will say like this: 50 bicycles and we have 7 colors. At least how many bicycles will have same color? That is the question. See this, at least how many is coming. As soon as you see this word at least how many and this type of keywords, immediately you will say, okay, this is the question of pigeonhole principle. So now they are saying at least how many bicycles will have same color. With guarantee they want to say. So what I will say, so you just, I am giving you proof of this pigeonhole principle. So you just consider the worst scenarios. 7 colors. Now you, for simplicity, I will take colors like Vibgyor. VIBGYOR. Okay. Violet, indigo, blue, green, yellow, orange, and red. 7 colors I have taken. 50 bicycles are there. So you try to separate them out. Like bicycle number 1, then 2. So bicycle number 2 is colored with indigo. Do not consider to paint second bicycle by same color. You just try to differentiate them. Okay. So then bicycle 3, then 4, 5, 6, 7. 7 bicycles are over. So 7 colors you have taken. So it's your wish. You can paint all the 7 by violet, all the 7 by indigo, all the 7 by blue, whatever way you want. But with guarantee I want to say, na, that's why I will take the worst scenario. You just try to take as many separate colors as possible. Okay, so it's just like that. Whenever you pick a bicycle, you try to color them with another color. You pick another bicycle, you try to color them by another color, and so on. just to make the variety or just to make bicycles more colorful, you have done like this. So now when 8th bicycle will come, what you will do, you have to repeat the color. This is for sure, guaranteed. So 8 will be this, then 9, then 10, then 11, then 12, then 13, then 14. Okay, so now I think you have got it now. So I will write it here, then 21. Okay, 28, 35, 42, 49. So how many we have painted? So 1, 2, 3, 4, 5, 6, 7. So 7 bicycles by red, 7 bicycles by orange, 7 bicycles by yellow, 7 bicycles by green, and so on. And the moment 50 bicycle will come, you have to paint it like this. So how many bicycles are painted? At least how many bicycles are painted with same color? 8 is the answer. How we have got 8? 50 by 7 ceiling function. That is nothing but 8. So this is the proof of your advanced pigeonhole principle. So I think you have got it. So this is guaranteed, na? At least these many bicycles will have same color. This is guaranteed. At least 8 bicycles will have same color. So this is guaranteed. You cannot have all bicycles by 7 color. You cannot paint them. Okay, why? Because for that we need only 49 bicycles. But the moment 50th bicycle will come, you will say 8 bicycle will have same color. Now, please try to focus here. Which color? I really don't know. This is not guaranteed that it will be violet color only. You can, it's your wish. You can paint it by indigo also, blue also, and so on. Which color? I do not know. Exactly how many bicycles will be painted by same color? I really don't know. Exactly how many, because this is a more powerful statement. Okay, so like this we can do all the color, all the bicycles, 50 to 50 bicycles I can paint by violet also. So exactly how many, I cannot answer this question, because to answer this question with guarantee I have to say, but with guarantee I cannot say anything like this. So exactly how many bicycles I cannot answer. I can answer at least how many, and which color I cannot answer. Which color? Let me write it. Which color? I cannot answer. Exactly how many? I cannot answer. Okay? These two questions cannot be answered. Only this can be answered, that at least how many bicycles will have same color. That's it. Okay? Yes. If anybody is having any doubt, please let me know.
No, sir. Clear.
Okay. So I think we should stop here only, or should I show you other questions? I think we should stop here only. Don't worry. Okay. From here itself, we will start the next class, because next questions will take few more time we have to spend on them, because if I will explain you on lesser depth, then obviously you will not be able to understand them. We will stop here itself. If anybody is having any doubt, you can ask me. Otherwise, we will stop the class here itself.
Yes, sir.
Okay then. Thank you so much. Good night. Bye bye.
Good night, sir.